Hello, everyone. I'm Lee Hongmei from number 3 Vocational Technical School of Nanning. Welcome to this mini lecture. In this lesson, we will learn about 3.1. The concept of network architecture. This mini lecture mainly consists of two parts. 1. The concept and components of network protocols. 2. Network architecture. The teaching objectives of this mini lecture are: 1. To understand the concept and components of network protocols. 2. To master the layers and relationships between network protocol layers. 3. To understand the advantages of using a layered model in computer network architecture. Now, let's begin with the first part, the concept and components of network protocols. First, let's consider a question: why do we need network protocols? Imagine if a Chinese person and a French person want to communicate, they need a common language. If they do not speak each other's native language, they might choose English as a means of communication. Here, English serves as a network protocol. It's a set of rules, a standard that allows devices from different backgrounds to exchange data smoothly. Network protocols are a set of rules, standards, or agreements established for data exchange among all devices on the network. They specify the format that information must adopt during communication and the meanings of these formats. Network communication protocols typically consist of three core elements: syntax, semantics, and timing. 1. Syntax. It defines the structure or format of data and control information. Similar to grammar rules in spoken language, it tells us how to organize our discourse. 2. Semantics. It determines the types of protocol elements, specifying what kind of control information needs to be sent, what actions to perform, and how to respond. 3. Timing. It specifies the sequence of information exchange, ensuring that the speed and timing of communication match. By now, I think you should understand how syntax dictates communication, what semantics convey, and when to communicate with timing. These three elements together ensure that both sides of communication in a network can exchange information effectively and accurately. Common network protocols include TCP or IP, IPX or SPX, and others. For example, the protocol used by the Internet is TCP or IP, which adopts a four-layered structure design, ensuring the network's flexibility and interoperability. The data link layer is responsible for transmitting raw bit streams over the physical network, while the network layer uses the IP protocol to facilitate packet transfer between different networks, although IP itself does not guarantee data sequencing or reliability. The transport layer further provides end-to-end communication services, with TCP ensuring reliability and sequencing of data transmission, while UDP is suitable for applications requiring high real-time demands but can tolerate data loss. The application layer directly serves various network applications for users, such as web browsing, file transfer, and email sending. Core features of TCP or IP include connectionless communication, reliability, routing, and congestion control, all of which collectively support the efficient operation and widespread applications of the Internet. Next, let's move on to the second part, the functions of computer networks. Let's explore the concept of network architecture. Network architecture is a collection of hierarchical structure models and protocols at each layer. It is designed to facilitate collaboration between computers, organizing the functionalities needed for interconnecting computers into well-defined layers. It specifies protocols for communication between processes at the same layer and interface services between adjacent layers, with each lower layer providing services to the layer above it. For example, computer networks use a vertical layering model to represent hierarchical structure. The hierarchical relationships within network architecture follow several principles. 1. Each layer's functions are clear and independent. In network architecture, Each layer has unique functions and responsibilities. For instance, the session layer is responsible for establishing, managing, and terminating communication sessions between two nodes in the network. Each layer focuses on completing its specific tasks without interfering with operations of other layers. 2. Layer N provides services to layer N+1. In network architecture, each layer acts as a service provider to the layer above it. This means each layer offers basic services or functionalities to the layer above it so that the upper layer can utilize these services to accomplish its tasks. For example, the transport layer depends on the network layer to select routes and transmit data packets. 3. Layer N, while implementing its own functions, directly uses services from layer N-1 and indirectly uses services from lower layers through layer N-1. Each layer utilizes services provided by the layer immediately below it to perform its functions. This allows each layer to focus on its specific tasks without needing to concern itself with the implementation details of lower layers. For example, the network layer uses services from the data link layer to send and receive data packets. Each layer in the network architecture communicates with its adjacent layer through an interface. And these interfaces are completely transparent to the upper layer. These interfaces define how layers interact, including data formats, signals, protocols, and more. The computer network architecture of the uses a layered model, which offers the following advantages. 1. Functional independence. Each layer can be developed and maintained independently of the others. 2. Flexibility. New services and functionalities can be more easily integrated into the network. 3. Abstraction of differences. Upper layers do not need to concern themselves with the specific implementation details of lower layers. 4. Ease of implementation and maintenance. Issues within each layer can be addressed independently without affecting the entire system. 5. Standardization. Facilitates the establishment of unified standards, promoting interoperability between different systems. Now, let's summarize the content of this lesson. We have learned about the three components of network communication protocols: the concept of network architecture, the hierarchy and relationships between layers, and the advantages of computer network architecture using a layered model. Finally, to reinforce our learning, I've prepared some exercises for you. I hope each of you will diligently complete them and internalize what you have learned. This concludes the mini lecture today. Thank you, everyone.